gears, and many other tribo components. While the thickener holds the oil and offers flow resistance, the oil performs the lubricating. Gears is given additives to increase its load carrying capacity, oxidation resistance, and corrosion control, similar to what oil lubricants do. So to simplify lang, ang sinasabi lang dyan is that the grease is a semi-solid liquid, consists of a thickener and liquid lubricant. So hindi siya magiging grease if it is only composed of liquid lubricant or just a thickener. So it's always the combination of the two. So to be familiarized lang with the thickener, yung thickener nagdi-disperse siya sa lubricating oils para makapag-produce ng stable colloidal structure or yung gel. So colloid, from the word itself, ito yung mixture in which one substance is evenly distributed throughout another substance. Ayun, so next. Okay, so ito yung mga possible na maging thickener. The first one is soaps. It is a metallic element such as lithium, calcium, sodium, or aluminum reacted with a fatty acid. The next one is fine particles of a lubricating additive such as polytetrafluoroethylene or PTFE. And the third one is the lead. Next po. Similar to oil lubricants, the additives are added to grease to improve load carrying ability, oxidation resistance, and corrosion control katulad ng na-mention kanina. Grease has complex rheology, hence it is a special lubricant. It has a multi-phase formulation which includes the presence of both fluids and solids. So, ano yung term na rheology? Kapag sinabi na rheology, ito yung term na ginagamit to describe and assess the deformation and flow behavior of materials. So, bakit kailangan ng rheology? Kasi syempre, alam naman natin na yung mga fluids, nagfo-flow siya at different speeds and yung mga solids naman can be deformed to a certain extent. So, ayun, mahalaga na malaman kung paano ginagamit yung rheology. Next. So it is also stated here that greases are not simply very viscous lubricating oils. Although the function of grease is very similar to oil, grease and oil are not interchangeable. Grease is used when it is not practical or convenient to use oil. Next. So now, let's discuss the uses for grease. Sabi dito, some applications particularly demand for grease while others are better suited for oil. Grease, for instance, is frequently used in first one is major operating conditions for machinery such as high pressures and temperatures, shock loads, or slow speed under heavy load. Grease produces a thicker lubricating film in these conditions. In many applications, oil is frequently too thin to provide adequate lubrication. The next one is for worn components. Grease can prolong the life of worn parts that were previously lubricated with oil because it retains thicker coatings and clearances enlarged by wear. The last one is components that may require greater lubrication. The advantage of using grease over many oil lubricated systems is that it needs to be replenished less frequently. Additionally, grease makes it easier to keep debris and dust out of the bearings. So, ang sinasabi lang dito is that yung grease, katulad ng lubricating oil, kailangan niyang magkaroon or ma-meet yung same requirement. Kaso, ang kailangan lang na condition ng grease is that kailangan mag-remain siya as a semi-solid. Kasi if magli-liquefy yung grease, yung likelihood ng lubrication failure is mag-i-increase. Kasi yung grease hindi siya effective as a cooling agent unlike oil na kayang makapag-remove ng heat by convection. So let's proceed to the manufacturing of greases. Next, please. So yun, manufacturing of grease is carried out either in pressurized vessels or open cooking. Kettles. Grease can be made in the following processes. The first one is batch process and the second one is continuous process. Next. Greases are manufactured by adding alkali and fatty acid to a quantity of oil. Then the mixture is then heated and soap is formed from the alkali and fatty acid. After the reaction, the water necessary for soap formation is removed and the soap crystallizes. Next. The final stages of manufacture involve mechanical working of the grease to homogenize the composition and allow blending in of additives and the remaining oil. Careful control of process variables is necessary to produce a grease of the correct consistency. Next one. Several cycles of mixing and maturing are often needed to obtain the required grease properties. Next. So now let's proceed to the composition of grease. Grease is composed of three major ingredients. The first one is base oil. It is used to provide lubrication. The second one is thickener to maintain a solid to semi-fluid state. And the third one is additives in order to provide special properties. Next one. So ang sabi dito, the base oil makes up about 80 to 90% of the mixture, 10 to 15% thickener, and 5 to 10% performance additives. Sometimes fillers such as metal oxides, carbon black, molybdenum disulfide, polytetrafluoroethylene, and others are also added. Next. So for the conclusion, generally speaking, oil works better in high temperature, high speed, and high friction applications. On the other hand, grease performs effectively in bearing applications which operate at moderate speeds and in environments with moderate temperatures. When the mechanism cannot be lubricated often, grease is also frequently employed because it adheres to the surface better. For instance, during stop-start operations, the oil returns to the crankcase but grease remains on the part where it is needed. Although oil and grease are used for the same reasons, to prevent metal-on-metal contact and protect equipment from wear and tear, they have different characteristics, each providing different benefits.
Hello po. So, to continue po yung report, mag-start na po tayo sa solid lubricants. So, next slide. Una nga is, what is solid lubricant? Lubrication is essential in the operation of machinery and equipment because it reduces friction and wear between moving parts. While liquid lubricants such as oils and greases are widely utilized, solid lubricants have gained prominence in a variety of industrial applications due to their distinct qualities. So, yung solid lubricants nga ay essential in decreasing friction and wear in variety of industrial application. So, yung distinct features nila including as high temperature stability and low friction coefficients make them as useful sa stability and low friction. Make them useful in harsh environments where liquid lubricants could fail nga po. Tapos, yan, start na tayo sa types. First type is graphite. Graphite is one of the most well-known solid lubricants. It is often used in high temperature and high pressure applications. It is consists of layers of carbon atoms that easily slide over each other providing low friction properties. Next slide po. So, yung second type po is yung molybdenum disulfide or tinatawag din na MOS2. MOS2 is another popular solid lubricant known for its excellent lubricating properties in extreme conditions. It has a layered structure din po, similar to graphite, and is often used in aerospace and automotive applications. Next slide po. The third one is tungsten disulfide or WS2. WS2 is a solid lubricant with exceptional performance in extreme temperatures, vacuums, and high-pressure environments. It is used po sa applications such as yung sa exploration and semiconductor manufacturing po. Next slide po. PTFE or yung polytetrafluoroethylene, commonly known as Teflon, yun po yung white if alam niyo yun, is a synthetic solid lubricant known for its non-stick properties. It is widely used din po sa industries including yung sa food processing and electronics po. Then proceed na po tayo sa applications. So, solid lubricants find applications in a wide range of industries including yung una po is yung automotive. So solid lubricants are utilized in engine components like piston rings and camshafts to improve fuel efficiency and reduce emissions po. Tapos sa aerospace naman, ginagamit ito sa aircraft components such as yung bearings to reduce friction and wear in extreme temperature and pressure conditions. Tapos sa manufacturing naman po, solid lubricants are employed in metal forming processes such as forming and extrusion to prevent tool wear and improve surface finish po. Next slide. Then sa electronics nga po, yan, ginagamit daw po siya sa precision components and sa connectors. Then sa food processing naman, sa conveyor belts and machinery. And sa space exploration po ay sa spacecraft and robotic systems. Yan, after po nung applications ay magpo-proceed naman tayo sa advantages and limitations. So, ang first advantage niya is sa high temperature resistance. Many solid lubricants can operate at extreme temperatures where yung mga liquid lubricants nga po such as yung oil ay nagbe-breakdown. Then sa low friction naman, it can provide very low coefficients of friction, reducing energy consumption and matagal po yung pagkasira. Sa longevity naman, solid lubricants can have a longer lifespan than liquid lubricants po. So yun po yung isang advantage niya. Reducing maintenance requirements po. Kaya sa chemical, cleanliness pala. Next slide na po pala. Despite their advantages, solid lubricants also pose some challenges po. So, sa limited speed, solid lubricants may not support heavy loads such as effectively as liquid lubricants po. Then, sa cost naman, some solid lubricants can be more expensive than traditional liquid lubricants po. Sa compatibility na naman po, sa compatibility naman with specific materials and conditions can be concerned, requiring careful section nga po. So, mas marami po yung sa ng compatibility ng sa liquid lubricants po kesa sa solid. So, yan lang. Next slide na po.
Hello po. Sunod naman po ay lubricant supply methods. Ang una po is self-contained units. For lubricating individual bearings, a self-contained device employing either straightforward mechanical recirculation or bath immersion is frequently enough. If there are significant power losses, cooling must be added to the system. Ito naman po yung formula na connected po dun sa self-contained units. The height to which oil will rise between closely spaced plates or in capillary tube can be solved using this given formula. H is equals to 2 times the value for surface tension multiplied by the cosine of contact angle all over R, which is the capillary radius multiplied by the density and acceleration due to gravity. Ito po ay example ng size speed limits for journal bearing lubrication method. Pangalawa naman po is centralized lubrication system. Since centralized lubrication system is also known as an automatic lubrication system, It is designed to optimize the lubricant delivery to the precise area where it is needed with the aid of computerized controls. Ganito ko po kung paano mag-work yung CLS or Centralized Lubrication System. The controller and injectors are programmed for specific amount of oil or grease to be delivered at designated intervals. When it is time for the lubricant to be applied, the controller activates the lubricant pump. Next is air is pumped into the lines to create the pressure necessary for moving the viscous liquid through the supply line into the injectors. Once the preset volume is delivered, a pressure switch deactivates the pump and any remaining lubricant is directed back to the reservoir. Centralized grease systems are designed principally to make the work environment safer for maintenance personnel by simplifying the process of accessing remote grease points, especially in confined spaces. The basic components of a centralized lubrication system. The exact layout of a centralized system depends on the type of system you choose. Whether you have a single line, progressive, or dual line parallel setup can affect the components and their layout, but most systems include the following basic components. Uh, CLS are basically designed po to automatically lubricate the moving parts that are usually generate friction. Ito naman po yung mga types of system na connected sa centralized lubrication system. Pump controller, supply line, air inlets, injectors, feed lines, and pressure switch. Ito po yung nabanggit ko kanina na nagwo-work within the system po para po mas malubricate yung machine po. Next po is circulating oil system.
The last method po is the circulating oil system. For greater oil demands in larger and high-speed equipment, a circulating system is brought into use with an oil reservoir, piping, a cooler, and filters. Mechanical system used in various industrial applications to circulate oil or lubricants through machinery to reduce friction, dissipate heat, and ensure proper lubrication of moving parts. And in simple words po, ang circulating oil system ay yung proseso ng pagpo-provide ng lubricants, specifically ng oil na alam naman natin na nagpapadulas ng mga joints ng makinarya para sa mas maayos at tuloy-tuloy na trabaho na ito. Next po. This table illustrates some useful information for determining reservoir capacity and pump requirements, filter type, and oil dwell for various applications. In the first column, makikita natin yung application kung ito ba ay electrical machinery, paper mill, dryer section, steel mill, heavy-duty gas turbines, steam turbine generators, or general industry. Sa second column naman ay nakalagay yung corresponding duty nito or yung function ng each application, and mapapansin natin na lahat sila ay bearings. The next column naman ay yung oil viscosity at typically at 40 degrees Celsius or 100 degrees when convert to Fahrenheit. Sa fourth column naman ay yung oil feed GPM or gallon per minute. The next is the pump type. Mapapansin natin na yung steam turbine generators yung nag-iisang centrifugal, and ano nga ba yung pinagkaiba ng centrifugal to gear pumps? Centrifugal pumps rely on kinetic energy rather than mechanical means to move the liquid, and mas mataas din yung na-offer na pressure ng centrifugal pump. The next column is the reservoir dwell time in minutes. And the second to the last is the filter type, and the last one is the filter rating in micrometer. This table represents the maximum tolerable viscosity which oil Stiffness blocks adequate oil flow, lubrication, and hydraulic functions in a machine. Next slide. Factors to be considered to achieve an effective circulating system. Number one is the pressure. Standard operating pressure is usually around 30 to 35 psi. Make sure you can adjust the pressure and obtain higher output if needed. But you may require a customized application for better system. Number two is the flow rate. It is important to have flow rate. Ito yung volume of fluid per unit time. It is important to have a good flow rate in space. Align the flow rate to what bearings need. Number three is the pumps and motors. There are motors in place with different voltage output and frequencies to derive optimal power results. The motor is fan-cooled and enclosed. Number four is the gauges. Lets you constantly monitor the operating performance. These pressure gauges are useful in verifying that the pump is functioning properly or not. Number five is the heat exchanger. It brings down the oil temperature before passing it to the bearing. Heat exchangers are crucial as they transfer heat from fluid or water. Mahalaga ang heat exchanger para ma-meet yung process ng heating and cooling. The next is the immersion heater. Its main purpose is to ensure the system starts without any hiccups or yung difficulties to deal with during cold temperature. The number seven is environment. Before designing the system, things like temperature, humidity, and the other important conditions must be taken into consideration. And lastly is the reservoir and piping. Piping in reservoir can be stainless steel or welded steel. The connectors are welded and fittings are flanged for a good connection. Yun lamang po ang aming report. Thank you po.
Good morning po, sir. Good morning po sa ating lahat. So, for the topic 3 po, we will be discussing about the bearing materials. Next po. So, under the bearing materials po, we have the following topics: distinctive material selection factors, oil film bearing materials, dry and semi-lubricated bearing materials, air bearing materials, high temperature materials, and rolling bearing materials. So, but before that po, let's discuss muna kung ano nga ba yung Bearing. So a bearing is a mechanical part that allows linear or rotational movement and reduces friction between two objects. If it prevents direct metal-to-metal contact between two elements that are in relative motion. So sa madaling sabi po, ang bearing materials ay ginagamit to support objects rotation. So specifically po yung shaft inside the machinery. So, ito po ay just to reduce the friction. So, saan ba kadalasang ginagamit ang bearing? Ito po ay ginagamit sa automobiles, sa mga sasakyan, or kaya po sa mga generator. So, yung tatlong tatandaan nyo lang when it comes sa bearing, yung kanya pong purpose ay to carry load, to reduce friction, and position moving machine parts. Next po. Next rip. History of bearing. So, wala po ito sa module. Ito ay nilagay ko lang para dagdag kaalaman nyo na rin. So, the first patent on ball bearings was awarded to Philip Vaughan, a British inventor and iron master in Carmarthen in 1794. So, sa kanya po naibigay yung patent or yung credits na siya po yung nakaimbento ng bearing materials. Pero many historians believed na yung first concept ng bearing materials ay mas matagal pa bago pa ma-upgrade or ma-develop ni Philip Bohan. So sabi dito, even before the creation of the wheel at the very beginning of human civilization, the concept of bearings had already taken shape. At that time, people realized that placing rolling logs beneath the heavy objects made it easier to drag them across a surface. So, hindi lang siya to reduce friction, yung purpose nila sa paggamit nito ng mga sinaunang tao, kundi para gamitin itong gulong para mas madaling i-move yung mabibigat na objects. Next po. So, para mas maintindihan nyo yung gamit ng bearing dahil marami sa atin hindi nare-realize na everyday ay mahalaga yung nagiging role ng bearing sa ating buhay. So, panoorin po natin itong video na ito.
Where would we be without bearings? Well, the short answer is nowhere. Bearings are so much a part of our everyday life that there isn't much that we can do without them. Without bearings, there's no way to reduce the friction between moving metal parts. Bearings contain tiny steel balls inside that allow for parts to roll around each other as opposed to against each other. Bearings reduce stress, allow for greater energy efficiency, and enable the prolonged existence of many day-to-day appliances. There are two main types of bearings, ball and roller bearings. Ball bearings, such as deep groove ball bearings, angular contact ball bearings, self-aligning ball bearings, and thrust ball bearings. And roller bearings, such as spherical roller bearings, taper roller bearings, cylindrical roller bearings, and needle roller bearings. Different shapes and sizes, designed to bring rotation to every part of our day. Bearings, creating a universe of motion so that we can get to where we need to be and do what we need to do easily. Mineral Circles Bearings, keeping the industry in motion since 1984.
So, sabi sa video, merong dalawang types ng bearing. Iyan nga ang ball and roller bearing. So, doon ipinakita rin yung iba't iba pang application ng bearing, which is ginagamit iyon sa wheels, sa washing machine, meron ding sa electric fan, and sa aircraft. So, next po. Distinctive material selection factors. For design purposes, consideration should be given to the compatibility of the friction pair, the embeddability and conformability, as well as the fatigue strength of the bearing materials. So ano nga ba yung mga bagay na dapat i-consider when choosing the right bearing? So first, compatibility. Next, embeddability and conformability. Strength, corrosion resistant, and thermal properties. Next po. Nandito nga pala yung list ng metallic elements at yung resistance nila when having a contact with low carbon steel. So yung metallic elements natin na may good resistance ay germanium, silver, cadmium, indium, tin, antimony, thallium, lead, and bismuth. So ito yung mga matitibay na metallic elements na kayang mag-resist ng too much friction. While yun namang nasa very poor na list, ang example ay silicon, titanium, chromium, iron, gold, palladium, and so on. Ito naman yung mga materials na considered na merong low resistance. Next po. So the first thing to consider sa pagpili ng ball bearing na gagamitin ay compatibility. So compatibility, it is the ability of the bearing material to resist physical or joining friction welding with the journal material when the direct metal to metal contact between the bearing and journal surfaces occurs. So yung compatibility, since yung bearing is responsible for the smooth movement and reduction of friction between two surfaces, it is very important to consider the compatibility of a bearing sa paggagamitan nito at compatibility ng mismong material ng bearing. So yung first reason kung bakit importante itong compatibility is that to avoid wear and tear. So given na gagamitin ang bearing to reduce friction, so it will undergo a certain stress and the pressure in different operation. So over time, nade-degrade yung quality ng bearing. Kaya kung gusto mong mas mahaba ang lifespan ng bearing mo sa iyong appliances, so dun ka sa mas matibay na materials, and yun nga yung na kanina na sa pinakita ko na list ng metallic elements with good resistances. So, isa pa, during friction kasi, when two different materials come in contact, magge-generate nga iyon ng heat during friction. So, yung heat, yung too much na init, can damage the bearing materials and as well as yung surrounding components nung machine na paggagamitan mo nung bearing. Next. So, hindi lang tayo sa materials ng compatibility magfo-focus. So, pag sinabi natin compatibility, yung tamang bearing. So, papasok din dito, kailangan din natin i-consider yung size ng bearing na gagamitin natin. So, ito naman ay madali na. Kung malaki yung machine mo, syempre, malaki yung gagamitin mo na bearing. At kung maliit naman, edi dun sa right size. Sabi dito, bearing comes in different sizes, shapes, and materials. So, ibig sabihin, kahit anong size ng machine na gagamitin mo, makakahanap ka nung right size ng bearing para dun sa purpose. Next po. So, ayan, choosing an incompatible bearing may result in excessive wear and tear or even failure of the machinery. So, ano nga bang mangyayari kapag nag-fail tayo sa consideration ng compatibility?
This is what happens when you drive on a bad wheel bearing. Completely rip the axle nut, the bearing, the rotor, the caliper, the flux hose. It's all still stuck inside the wheel.
Ayun, so based dun sa video na pinanood natin, so sabi niya yun daw yung mangyayari kapag daw gumamit ng bad bearing. Ibig sabihin siguro yung ginamit niyang bearing, it's either mahina yung quality or alam niya na nung una na may sira pa pero hindi niya pinalitan. So yun nakalagay sa caption na, "This is what happen when you don't replace your bearing." Yung nangyari sa kanya, pumalya yung bearing, nasira, and then yung wires and other components nung gulong ng sasakyan ay umikot dun sa mismong wheel or dun sa mismong bearing. So yan, nag-fail yung kanyang bearing. So the next consideration when choosing a bearing is the strength, and it will be discussed by Rip Van Winkle.
Corrosion resistance. Isa pa pong property na meron ang bearing ay dapat corrosion resistant din siya. Ano nga ba pag sinabing corrosion resistant? Full ceramic bearings made from zirconia or silicone nitride with PEEK. Yung yung PEEK po is yung polyether ether ketone or yung pinaglalagyan po nung bearing. Yung trabaho po ng PEEK ay pine-prevent po yung pagpasok ng mga moist or mga tubig sa isang bearing na nakasubmerge po sa tubig. Similarly, plastic bearing with 316 stainless steel or glass balls have very good resistance to corrosion. Ah, ang isa pa pong pwedeng gamitin na bearing na highly corrosion resistance ay yung plastic bearings. Next po. Bearing alloys containing lead, copper, zinc, and cadmium are susceptible to varying degrees to corrosion by organic acid and peroxides formed in lubricating oils that have become oxidized in service. Itong mga materials na ito, mga lead, copper, zinc, cadmium, ito yung parang sila yung mabilis tamaan ng mga corrosion na sa isang type ng bearing. Alam naman natin kapag ang isang material ay tinamaan ng corrosion, lalong-lalo na ang bearing ay gumagalaw tapos sobrang importante ng bearing na dapat compact siya, hindi siya umaalog. Kapag may konting alog, maaaring ma-damage yung ating mga equipment. This difficulty can be minimized by selecting oxidation inhibit oils, avoiding high bearing operating temperatures, and changing the oil regularly. Ito naman, sa part na to, ang isa pang sinasabi nila para maiwasan yung corrosion, dapat mini-maintenance mo din yung bearing mo, hindi lang siya ilalagay lang. Dapat regularly ay kumbaga nililinis mo ito. Next slide po. Ang isa pang kailangang ng bearing ay thermal properties. Heat causes metal to expand, which can create wrapping issues. When the metal in a bearing expand, it can reduce the clearance between the ball and the raceway. Dito sa part na to, ang pinakamagandang example natin ay yung mga bearings sa part ng engine. Kasi alam naman natin ang engine ay sobrang init kapag umaandar, tapos depende sa type ng engine kung ilang RPM. Ang RPM ng isang engine ay ranging from 1,000, tas merong umaabot pa ng up to 15,000 na sobrang bilis. Kapag ang isang bearing ay nag-expand tapos nagkaroon ng mga gaps or nag-drop, hindi tatakbo ng smooth yung engine at pwede mag-cause ng knocking. This change in clearance can cause the bearing to tighten, which can eventually force it to seize up and fail. Thermal conductivity minimize temperature increase, particularly during initial running of bearings and during high speed and high load operation. Plastic bearings usually are avoided in high speed equipment where their poor heat transfer may lead to charring of plastic and overheating of the journal. Yung sinasabi sa part na to, yung mga plastic bearing daw ina-avoid during high-speed equipment, kagaya ng halimbawa nga sa engine. Hindi nila hindi nila nilalagay yung mga plastic na bearing sa mga maiinit na component ng isang engine dahil hindi siya compatible o hindi niya kayang gawin yung pinakatrabaho niya, which is ang pagiging corrosion resistant. Ang nilalagay dito sa sa part na to ay yung mga materials na highly thermal resistant. Kumbaga, kaya niyang i-withstand with yung mga high temperatures and nag-ooperate pa rin siya smoothly. Next po.
So now we will be discussing the oil film bearing materials. So fluid film bearing materials are mechanical components created to generate a load support for mechanical components and to promote smooth, low friction motion between solid surface in relative motion. Any liquid, gas, or even solid substance can serve as the lubricant or fluid between the surface. Fluid film bearings have a significant impact on the performance of rotating machinery because when properly designed and maintained, they can handle both static and dynamic loads. Though there are a lots of fluid film bearings, we will only focus on the oil film bearing materials. So, ang di-discuss natin ay yung bobbits, copper alloys, aluminums, cast iron and steel, silver and zinc. Next slide po. So, the first one is bobbits. Because of their superior compatibility with steel shafts, ability to embed foreign particles due to their softness, and unique ability to adapt to misalign by mild wiping on initial run-in made possible by their low melting points. Lead and thin white metal alloys, patented by Isaac Babbitt in 1839, are frequently the first choice for bearing materials. Because of how delicate and fragile these low alloy compositions are, fatigue resistance and compressive strengths are frequently compromised. Tin bobbits are frequently used in place of lead bobbits due to their superior corrosion resistance, ease of bonding, and reduced propensity for segregation, although being more expensive. So, ang bobbits ay mostly used or commonly used for oil-filled bearings since, as stated nga sa report, yung compatibility and conformability is top tier compared sa ibang materials. Kaya for most parts, bobbits is the go-to materials ng mga gumagamit para sa oil film bearing materials. Ganito nga pala ang itsura ng bobbits. Next slide. Next na po.
So, proceeding to copper alloys for oil film bearing materials. So, copper-based bearing alloys is one of the materials used in the manufacturing of bearings. So, these alloys are primarily composed of copper as the base metal, and they are alloyed with various other elements to enhance their mechanical properties and suitability for bearing applications. So when selecting a copper-based bearing alloy, it is essential to consider the specific requirements of the application to ensure that the chosen alloy meets the desired performance criteria. Next slide po. So for the characteristics of typical copper-based bearing material, so ipapadiretso ko na po sa table para po mas makita nyo kung ano po ba yung mga materials designation and composition. So next slide po. Next slide po ulit. So, sa first column, we have yung materials listed for copper-based bearing alloys. For the second column po is we have the designation in which nakalagay yung UNS and SAE. So, UNS stands for the Unified Numbering System and SAE stands for the Society of Automotive Engineers. So, yung both systems na to are used for identifying and classifying materials, particularly for metals and alloys in various industrial applications. For the third column is yung composition. So this composition includes, since copper nga is the base metal for this type of alloys, so nandito yung kung ilang percent ba yung copper and yung other alloying materials. So we have copper, so tin, lead, and zinc. Next is fourth column, we have the Brinell hardness. So it is a measurement of material's hardness, specifically its resistance to indentation or deformation when a standardized ball or indenter is pressed into the material surface. And then for the fifth column, we have the ultimate tensile strength measured in megapascals. And for the last column is the initial melting point measured in degrees Celsius. So dun po sa mga alloys which are on the top of the list, may higher they contain higher lead content. So they are commonly given first consideration since they have better compatibility and resistance to scoring. So when higher strength, hardness, and wear resistance are required, yung mga alloys naman po na nasa bottom of the list with increasing tin and aluminum content are selected. So yung mga higher hardness tin bronzes such as gunmetal alloys, so they require reliable lubrication, good alignment, and 300 to 400 minimum Brinell shaft hardness. So with their inherent strength, they are not commonly cast on a steel backing. So yung mga aluminum bronzes naman po, they provide excellent strength as well as shock and wear resistance in bushings and bearing plates for machine tools, aircraft landing gear, and other rather special applications. Next slide po. So this is a picture of what copper alloys look like. Next slide po. So now proceeding to aluminum oil film bearing material. So these alloys naman po are primarily composed of aluminum as the base materials along with other alloying elements that enhance their mechanical properties and wear resistance. So, proceed po ulit dun sa table. Thank you po. So, for aluminum, wait pa ano nga ulit. Next slide. Thank you. So for aluminum, meron din ulit dun sa unang column, we have the material and ang ginamit nilang system is the SAE designation. And then next is sa sunod na column, we have the alloying elements. So since we have aluminum as the base metal, ito naman kung ilang percent pa yung other alloying elements such as silicon, copper, tin, nickel, lead, cadmium, and magnesium. And then dun sa last column, we have yung type of bearing niya which could either be solid, bi or trimetal, cast, rolled, or rough. So these alloys listed in the table offer high fatigue strength and excellent corrosion resistance, high thermal conductivity, and low cost. So alloying with tin is common for improved compatibility along with 1.5 to 11% silicon and up to 2% copper. So yung mga special aluminum alloys with much higher tin which are written as which are given the code SAE 783 and 786 and those with lead content which are SAE 787 have been developed with specialized processing techniques to eliminate the need for an overlay. The performance of high-tin alloys led to their dominant use in European automotive bearings. Yung mga medium tin naman, which are SAE 788, is employed as a surface layer in bimetal bearings for connecting rod, main, and camshaft bearings, as well as for thrust washers and pump and transmission bushings. So while yung high lead alloys naman have found widespread and successful use pagdating sa mga automotive bearings, pero since may high cost siya, limited lang siya for continued use. Next po.
Good morning po. For next oil film bearing materials po, meron po tayong cast iron and steel. According to Dean and Evans, flake graphite in gray cast iron allows bearing machine directly in structural parts to carry loads up to about 1 megapascal or 145 psi at surface speed up to about 0.8 meter per second. For such applications as pivots and lightly loaded transmissions, with good alignment, copious oil feed, and hardened and ground journals load range up to 4.5 megapascal or 650 psi for main bearings in cast iron refrigeration compressors and up to 5.5 megapascal or 800 psi for connecting rods. A phosphate etched surface is commonly applied as an aid for initial run-in. Yun po, in-indicate po dito yung different carry loads up in cast iron to prevent wear or scoring issue. Like yung flake graphite po in gray cast iron enables bearing machine directly in structural elements to carry loads up to 1 megapascal or yung 145 psi at surface speed up to 0.8 meter per second. Then cast iron refrigeration compressors main bearings naman po are capable of supporting loads up to 4.5 megapascal or 650 psi and connecting rods are capable of supporting loads of up to 5.5 megapascal or 800 psi. Next po. For stresses up to 1.4 megapascal or 200 psi at speed up to 0.8 meter per second, structural steel parts can also be easily machined using guide surfaces and journal bearings. Extreme pressure and anti-wear compounds in oils help prevent wear and scoring issues. Then ito naman po yung sa steel. Structural steel parts can easily machine po for stresses up to 1.4 megapascal or 200 psi. And ayun po ang extreme pressure and anti-wear compounds in oils is a big help to prevent wear and scoring issues in steels. Next po. So yan po yung picture ng cast iron and cast steel. Next po. Ang next pong oil film bearing material is silver. According to Dehart, bearings consisting of 0.3 millimeter of silver electrodeposited on a steel backing with a 0.025 or to 0.10 millimeter lead babbitt overlay have given excellent performance in diesels, superchargers, and connecting rod and main bearing of reciprocating aircraft engines. Unique self-healing and excellent compatibility in rubbing on steel make thin electroplated silver useful as a bearing material under severe sliding condition in a variety of special prototype and experimental machine. Nagbe-benefit daw po dito ang diesels, superchargers, connecting rod, and main bearings of reciprocating aircraft engines from the excellent performance of bearings made. Then the thin electroplated silvers, unique self-healing, and excellent compatibility in rubbing on steel make it useful as a bearing material. Next po. Yan po yung picture ng silver. Next po.
So, ang last oil film bearing materials po na aking i-discuss ay ang zinc. Zinc alloys used for better wear life and lower cost replacement for SAA 660 and other bronzes. Ang composition po nito ay nagko-contain about 10 to 30% aluminum for improved properties, are formed as cast tube for use as solid alloys and brushings, according to Kingsbury 1997. Oscillating and rotating applications are made at speed up to 7 meter per second or 1,400 feet per minute sa temperature up to 9 to 125 degrees Celsius. Next po. So, yan po yung image ng zinc. Next po. So, ang sunod ko pong i-discuss ay about sa dry and semi-lubricated bearing materials. So, ang madalas na ginagamit na in dry sliding ay ang extensive variety of polymers and their composites, porous metal bearings, carbon graphite, wood, and rubber, with process fluids such as air, water, and solvents or other conditions or spares lubrication. They commonly allow design simplification, freedom from regular maintenance, and reduce sensitivity to contamination. While these materials are usually applied at low speed with minimal lubrication, performance normally improves the closer the approach to full film lubrication. So ngayon ay isa-isahin natin yung mga materials na ginagamit in dry sliding. Next po.
Ang i-report ko naman po ay about po sa plastic po. Any of a group of synthetic or natural organic materials that may be shaped when soft and then harden, including many types of resins, resinoids, polymers, cellulose derivatives, casein materials, and proteins. Used in place of other materials as glass, wood, and metals in construction and decoration for making many articles as coatings and drawn into filaments for weaving. Ah, yung ilang pong application po ng plastic po ay makikita po natin sa produce packaging, in building and construction, in textiles, consumer products, transportation, electrical and electronics, at industrial machinery po. Next po. Next slide po. Ay, yung ano po. Ayan. The most widely used thermoplastics are nylon, acetyl resins, PTFE, and those produced in large quantities by polymerizing gases from petroleum cracking such as polyethylene and polypropylene. Nearly all commercial plastics are used both dry and lubricated for sliding contact at low speeds and light loads. Phenolics, polyesters, and poly- polyamides are the thermosetting resins most frequently utilized in bearing applications. So yung thermoplastic po ay class po ng polymer na pwede pong mapalambot gamit po ng pagpapainit dito at pwede din po itong ma-process po gamit po ng methods such as extrusion, injection molding, thermoforming, and blow molding. Next po. So ito po pala yung mga itsura po nung example po ng thermoplastics. Yung una po ay nylon. So nylon is any of numerous strong, tough elastic synthetic polyamide materials that are fashioned into fibers, filaments, bristles, or sheets and used especially in textiles and plastics. So some example po ng nylon ay ginagamit po sa seat belts, fishing nets, at tire cords po. Yung next po ay acetyl resins. Yung acetal is a synthetic plastic that is often used when injection molding or extruding. Acetal resins have well-balanced properties, including a hard, self-lubricated surface and excellent chemical resistance, strength, stiffness, and toughness over a broad temperature range. So, some application po ng acetal resins po ay yung mga mechanical components po na katulad po ng gears, pumps, valves, nuts, and fasteners po. So, ang sunod po ay yung PTFE o yung polytetrafluoroethylene, which is a synthetic fluoropolymer of tetrafluoroethylene. Being hydrophobic, non-wetting, high density, and resistant to high temperatures, PTFE is an incredibly versatile material with a wide variety of application, though it's perhaps best known for its non-stick properties. Dahil nga po dun sa mga properties po na nabanggit ko po, ang pinaka-common po na application po ng PTFE ay yung tinatawag po nating non-stick coating for cookware po. Next po. For a wide range of lightly loaded applications in home appliances, office equipment, tiny industrial devices, toys, and instruments, injection molded acetal and nylon provide affordable compact bearings. The polyamide nylons have low friction, little to no lubrication need, and quiet operation. By adding fillers like inorganic powders or glass fibers, or by putting the nylon as a thin layer over steel support, problematic cold flow of nylon under load is reduced. In appliance, automotive, and industrial applications, acetal and ultra-high molecular weight polyethylene are frequently used to create affordable housings, gears, and other machine elements of which bearings are only a portion. Next po. The The synthetic resin polymerized from tetrafluoroethylene is called polytetrafluoroethylene or PTFE, and it is strong, robust, waxy, and non-flammable. Teflon, Floon, Hostaflon, and Polyflon are just a few of the trademarks that are used to identify PTFE. It also stands out for having a slick surface, a high melting temperature, and being resistant to practically all chemicals. In addition to being fabricated into industrial goods like bearings, pipe, liners, and components for valves and pumps, its qualities have made it popular among consumers as the coating on non-stick cookware. Gaya nga po ng sinabi ko po kanina po, ang application po ng PTFE po ay yung ginagamit po sa non-stick pan po, yung mga ganun po. So next po. Commonly utilized as composites with cotton fibers, cellulose, or graphite are inexpensive phenolic resins. Appliances, office equipment, and instrumentation are examples of modest applications. In phenolic or polyester structural parts, bearings are frequently just holes. Larger bearings in industrial and marine applications typically cannot use them due to high processing costs. The more popular type of thermoplastics below a 50 mm bore size are injection molded ones. So yung next part po ng presentation po ay present po ng next presentation na si Emmanuel Bello po. Next po.
So yun po, hello and good morning sa inyong lahat. Ang next na dry and semi-lubricated materials naman po ay ang carbon graphite. So ano nga po ba yung carbon graphite? It is a material that is used for replacement and specialty parts because when prepared properly, it offers wear resistance, high temperature capabilities, self-lubricating properties, and the ability to be used in corrosive materials. So, ang carbon graphite po ay napasama sa materials na dry and semi-lubricated dahil meron na po itong self-lubricating properties. At kapag po na-prepare ng tama ay nakapag-offer po ito ng resistance at high temperature capabilities. Next po. So the word itself na dry and semi-lubricated bearing materials po ay ito lang po ay ito po ay material lang. Hindi po ito katulad ng mga oil or grease na kung saan sila na yung lubrication itself. So para po i-prepare ang ating carbon graphite ay dumadaan pa po ito sa high pressure molding na may kasamang petroleum coke, lamp black, and coal tar pitch na sunod na process naman po ay pag-cure dito up to 1,440 degrees Celsius. And after that molding, hindi pa po siya tapos kasi minsan sa pagmo-molding natin, meron pa pong mga natitirang parts na kumbaga po ay nagfo-form ng mga butas. And para po matakpan yung mga butas na yun, nilalagyan po ito ng phenolic and epoxy resin or epoxy resin, copper, babbitt, bronze, glass, or silver to give wide range of strength, hardness, and wear properties. So, ang mga ganitong mga materials naman po ay ginagamit sa mga pump bearings for water, gasoline, and solvent, conveyors, and furnace bearing at temperatures up to 400 degrees Celsius. Next slide po. So, next naman po ay rubber. Synthetic rubber is commonly used in water-lubricated journal bearings as a series of eggshell segments separated by longitudinal grooves for supplying the water. The rubber stubs in turn are enclosed in a rigid bronze cylindrical shell. So next material naman po ay rubber. So gaya po ng carbon graphite, piniprepare pa po yung rubber. Hindi po siya yung pinaka-lubrication itself. So ang commonly na process po dito ay yung mga nilalagyan ng water and oil solution na kung saan po ay ilalagay lang to sa surface ng rubber na kung saan nadadaanan ng iba pang material na nagpro-provide po ng pinaka-lubricate na lubrication niya. So, the rubber stubs po ay ito pong the rubber stubs ay makikita natin sa next picture. Ay, next slide. So, yan pong picture na yan ay yung stubs na kung saan ay nilalagay po siya sa mga cylinder na ng metal na kung saan po ay nag produce ng pinakabalot do sa inner diameter niya na kung saan pag po pinasukan ng isa pang metal ay hindi na po siya sobrang sikip ganon and pampadulas din po talaga siya. And resilience of rubber and its ability to embed dirt particles and to resist abrasion bring rubber bearings into general use for marine propeller, shafts, water turbines and pumps, and conveyors for slurries of gravel and ore. Non-corrodable shaft surfaces or sleeves are commonly composed of bronze, monel, chrome plate, and stainless steel. So ang commonly used po ng rubber as a lubricant material ay sa mga marine propeller shafts po, sa mga turbines and pumps. Yun lamang po. Next na po.
So, yun po. From ang last one po for the dry and semi-lubricated bearing materials ay ang wood po. It is used to be common for making things like machine parts, but now we mostly use plastics, especially metals with holes and rubber for these jobs. These new materials work well when machines need to move things like water and other thin liquids. So yun po, yan po ang kadalasan pong ginagamit, pero ang ginagamit po ngayon po talaga sa mga machine parts is plastic, special metals and rubber po. Para po yung materials work well when machine needs to move things like water po. Next po. Next po. Yun po. For the air-bearing materials naman po, unique materials are being used more and more with air as the stuff that help things move smoothly. We see these materials in airplane parts that spin fast and things that lift heavy stuff easily, and even in the hard drives of our computers. They work well in these places because they reduce friction and help things move smoothly. So yun po, doon po natin po ito kadalasan nakikita po sa mga airplane parts at syempre po sa hard drive po sa atin pong computer because they reduce friction and help things move smoothly po. Next po. So yan po yung sa air-bearing materials, makikita niyo po sa picture. Nandyan po yung bump foil, top foil, foil bearing, bearing sleeve, and journal. Next presentation na po.
Good morning po. Ang i-discuss ko naman po is a type of air-bearing materials which is foil air bearing. Ano nga ba yung foil air bearing? So, these are wide use in oil-free aerospace turbo machinery such as turbochargers and cabin air cooling and pressurizing units. And ito ay type of air bearing where the surface is supported by a compliant spring-loaded foil journal lining. And once the surface is spinning fast enough, the air pushes the foil away from the surface so that no contact and no force. The surface and foil are separated by the high pressure from the air generated by the rotation that pulls gas into the bearing via the viscosity effects. And sabi dito sa aming PPT, ang foil air bearing daw ay may equation na ginagamit. And ito ay ang W is equals to K sub W times L times D times omega. So, ano nga ba yung W sa ating equation? Ang W is the maximum steady state load that can be supported. So, ang unit na ginagamit is W is LB or yung tinatawag nating pounds. And then, ano nga ba yung K sub W? Ang K sub W, it is a varying load capacity coefficient, LB per unit inch cube KRPM, and K sub W has increased to 1 or higher in recent application from 0.3 to 0.5 in earlier foil bearings. On this basis, loadings now are generally on the order of 30 psi on the projected bearing area. And then, ano nga ba yung L dun sa ating equation? Ang Li, yung bearing axial length natin, and yung unit na ginagamit dito is inch. And then, pagdating naman sa D, lagi naman andin natin yung diameter, which is the shaft diameter, and ang gamit din na unit is inch. And the last is the omega, which is the omega na symbol is a shaft speed in 1,000 RPM. So, sa pagdating sa sa problem, kapag ang given ay naka RPM, i-convert muna natin ito into KRPM. So, para mas madali nating maintindihan ng equation na to, ating i-apply ito into problem. So, next slide po. Yan, example. So, a 2-inch diameter air lubricated foil bearing is to carry 180 lb radial load of 20,000 RPM. What is the minimum actual bearing length required? So, paano na natin gagawin is, ilalagay muna natin yung given para hindi tayo malito. So, base sa ating problem, meron daw tayong diameter na 2 inch. And the next is yung omega. So, sabi ko kanina na kapag RPM yung nasa problem, i-convert natin into KRPM. So, nasa given natin is 20,000 RPM, convert to KRPM, which is 20 KRPM. And the next is the W, which is 180 lb or pounds. And by rearranging formula po, kasi nga ang hinahanap natin ay minimum actual bearing length, and gagamitin natin kay sub W is equals to 1. Pagdating naman sa formula, kanina, double, dun sa binigay kong formula is double yung hinahanap. Pero dito sa ating example is ang hinahanap is minimum actual bearing length. So, i-rearrange natin yung equation. L is equals to W over K sub W times D times omega. So, the next is yung solution natin. Ang pagdating sa solution natin ay direct substitution lang dahil na-identify na natin yung mga given. So, L is equals to 180 lb over 1 times 2 times 2 times 20. And then, pag nakalkinan natin to, ang sagot ay 2.25 inch. Yun lang po.
Next po, we will talk about air bearings, which are like special cushion used in various machines. Now we will look at two cool ways we use this cushion for lifting heavy stuff and inside our computer hard disk. Air lifts. External pressurized air bearings are used for moving heavy loads of materials and machinery. All-terrain vehicles and bulky loads can be raised up to 3 inches. Material selection is customized to the application. Porous traction of graphite, ceramics, and sintered metal distribute airflow uniformly. This prevents misalignment and air wastage. Imagine you have a magic cushion that can lift really heavy metals like cars and machines. We can customize the material of this cushion to make them perfect for the job. They even have tiny holes in them to make sure the air goes everywhere evenly, so nothing gets stuck. This helps us move heavy things without any problems. Next slide. Air lifts. Key points. Ideal for heavy loads, customize material selection, utilize porous structure for uniform air distribution. Prevents misalignment and air wastage. To sum it up, these cushions are great for lifting heavy stuff. We can choose special materials for different jobs. They have tiny holes to make sure the air spreads evenly No air goes to waste, making it super efficient. Next slide po. Computer hard disk drive. Air bearings play a critical role in modern hard disk drive. Magnetic recording involves motion between a read write head and magnetic disk. Air bearings mainly a tiny film distance as low as 3 nm. These materials typically include aluminum or glass coated with a magnetic film. It Here what hard disk looks like. It has a special disk made of aluminum or glass. There's a thin layer on the disk that stores all your data. This layer is covered with a super hard material to protect it. It even uses special oil to keep everything moving smoothly. Tiny bumps on the disk help things run even better. Next slide po. Hard disk drive structure. Typical hard disk structure: aluminum or glass disk, thin, complex magnetic film, cobalt alloy applied by sporting diamond-like carbon layer for wear protection, fluoriether, synthetic oil for lubrication, laser-generated bumps for improved friction and wear performance. Next slide po. Air bearings in hard disk drive. Air bearings in hard disk drive are crucial for maintaining a tiny or air film between the head and the disk. The read-write heads are fabricated on Al2O3 over TIC ceramic wafers known for their high hardness and wear resistance. A precision locked-in magnetic operated film is deposited on the head. The head slider is mounted on the suspension to record and retrieve data from the disk surface. These cushions are like magic. They keep the head incredibly loose, close to the spinning disc. The heads are made from special hard materials. They put a super thin magnetic layer on the head to do their job. The head is mounted on something flexible to follow the spinning disc and read your data. Next slide po. Key takeaways. Air bearings are versatile and find application in various industries. Air bearings are used in different machines. They lift heavy things and keep computer data safe. Choose the right materials is super important. The discussion are like secret helpers inside our device. To wrap it up, air bearings are amazing and used in many ways. They help us lift heavy stuff and store information in our computers. Remember, the right materials and careful design make them work like a magic. Next slide po.
High temperature materials. Next slide po. Okay. When temperature limits for lubricating oils and the usual solid lubricants are exceeded, quite different bearing materials must be selected to operate either dry in slow-speed sliding or with poor lubricating fluids such as gas, liquid metals, or pressurized water. So, ibig sabihin lang po nito, kapag po na-exceed na ng temperature yung limits ng ating lubricants, magiging less effective na po ang ating lubricant. So, ang other solution lang po talaga dito ay palitan na ang materials for bearing. Para po hindi agad ito masira or mag-wear out. Next slide po. Okay. Alloys of cobalt, nickel po, chromium and molybdenum, such as those enlisted in table 4.7, ay sila po yung mga elements or materials na may high temperature, strength, and reasonable friction and wear characteristics. According po kay Glaser, ang ilan po dito sa mga materials nito ay stellites with chrome carbide dispersed in a cobalt matrix and cobalt or nickel-based triballoys, which develop hardness by an intermetallic lave space rather than massive carbides. Next po. Okay. Ito po ang ating force orientation para sa ating um, head disc interface. Meron po tayong TE or trailing edge of slider. Meron din naman po tayong downward force, which is yung preload ng ating air bearing force, which is yung upward force, at saka another downward force po yung adhesion force, at saka contact force po, which is yung from the tip of the slider po. Next po. Okay. The following approximate transition temperatures: a smooth oxide surface forms in air with sufficient rapidly to minimize metal-to-metal contact and provide a lower rate. So ito po ang such alloy, distinct metal alloys, which is steel at 185 degrees Celsius, cobalt at 350 degrees Celsius, molybdenum at 460 degrees Celsius, titanium at 575 degrees Celsius, chromium at 630 degrees Celsius, nickel at 630 degrees Celsius. Next slide po. Okay. Aluminum oxide and silicon carbide po are usually used for bearings and seals, while ang silicon nitride naman po ay usually used in ball material for use the tool steel raceways. Ang raceways po ay kumbaga po ay para siyang enclosed conduit na nagpo-protect sa wire. Na ang main purpose po ay to protect the cables from heat, humidity, corrosion, water intrusion, and other general physical threats. So ito naman po yung nabanggit natin na aluminum oxide or hot press alumina na may density na 3.9 to 3.98 gram per cubic centimeter, hardness na 2,050 kilogram per cubic millimeter, modulus elasticity po na 380 to 400 gigapascals, tensile strength at 260 megapascals, flexural strength at 260 megapascal, compressive strength, which is 2,760 megapascal, fracture toughness, 3 to 3.2 megapascals, and thermal shock resistance is 4.10. Ang silicon carbide naman po ay mayroong 3.10 density gram per cubic centimeter, hardness na 2,800 kilograms per cubic millimeter, modulus elasticity at 410 gigapascals, compressive strength at 3,900 megapascals, fracture toughness at 4.6 megapascals, and thermal shock resistance at 10. We have at silicon nitride naman po or yung tool steel, we have a density of 3.21 grams per cubic centimeter, hardness at 1,500 kilogram per cubic millimeter, and modulus elasticity of 325 gigapascals, tensile strength of 524 megapascal, flexural strength is 524 megapascal, compressive strength is 3,000 megapascals, fracture toughness is 6 to 7 megapascal, thermal shock resistance 20, and maximum use temperature in air is 1,300 degrees Celsius. Next po. These ceramics offer high compressive strength and fatigue resistance, corrosion resistance, low density, and retention of mechanical properties up to temperature well above 1,000 degrees Celsius. High wear rates of 1 times 10 raised to negative 4 up to 1 times 10 raised to negative 6 square millimeter per Newton meter per unlubricated ceramic couples ay pwede daw po siyang i-reduce with lubrication to 1 times 10 up to raised to negative 7 up to 1 times 10 raised to negative 10 or less. Ang usual pong ginagamit para mag-reduce para ma-reduce po ito are yung lubricants po that include oils, greases, water vapor, aqueous solution, low shear strength solids, reactive vapors, and friction polymers. Pero temperature above 250 to 300 degrees Celsius naman po, ang madalas na ginagamit na lubrication po ay vapor-phase lubrication, solid lubricant films, and oxide films formed by environmental reaction. Next slide po. Okay. Cracking under thermal shock is always a concern with ceramic components. Frictional surface heating during sliding can involve rapid rise and fall of temperatures. Low thermal conductivity and high elastic modulus make a material more prone to this thermal shock and rupture as reflected in its thermal shock resistance. So ito po ang ating formula, thermal shock resistance. We have tensile fracture multiplied by the thermal conductivity all over elastic modulus times thermal expansion coefficient times 10 raised to negative 3. Next slide po. Yeah. The lower the TSR, the higher the sensitivity to thermal shock fractures. Ang pinakamababa pong range ng TSR lagi ay ang stabilizer cone niya. Ang sunod naman po ay ang pinakamataas naman po pagdating sa ceramic, which is ang silicon nitride, which is ang TSR range po niya ay up to 20. Which is ang pinakamataas naman po ay ang tool steel na may TSR ranging na up to 57 po. The critical sliding velocity above which thermoelastic instability is encountered by approximately B proportional to TSR. Proportional po kasi pagtaas po ng ating TSR, mas na tolerate niyo po yung thermoelastic instability ng isang material or pag nag-undergo na po siya ng work. Thermoelastic instability is associated with high-speed sliding contact where pressure perturbations appear in the contact. As a result of local thermoelastic expansion and high contact pressures, an unstable thermal loop is set up that often leads to the formation of macroscopic hotspots or macroscopic hotspot po ay usually nangyayari po doon sa sa area po ng contact force kung saan nagkakaroon ng sliding and change of temperature or friction. Next slide po. And let's apply the formula po. Determine the thermal shock resistance for a tool steel with the following properties: tensile strength of 2000 megapascals, thermal conductivity of 51.9 knots per meter degrees Celsius, elastic modulus of 200,000 megapascals, and thermal expansion coefficient is 12.1 times 10 raised to negative 6 m over m degrees Celsius. Simply, ating i-substitute lang po ang ating value sa ating formula, which is TSR is equals to tensile strength times thermal conductivity over elastic modulus times the thermal expansion coefficient times 10 raised to negative 3. Okay. Now, as we substitute it, we have 2 times 51.9 all over 200,000 times 12.1 times 10 raised to negative 6 times 10 raised to negative 3. And if in-insert na po natin sa calculator, ang makukuha po natin is 42.89256198 or kapag ni-round up po natin siya sa whole number, we have 43. Yun lang.
So yun po, good morning po. Bali po, next topic po natin is yung rolling bearing materials po. So, rolling bearing materials. So, steels for ball and roller bearings are commonly selected to provide Rockwell C hardness, in the 58 to 63 range at load carrying contacts. Below this level, fatigue strength drops rapidly for contact stresses commonly in the 700 to 2800 MPa or 100,000 to 400,000 psi range. Troublesome brittleness is encountered at higher hardness levels. So yun nga po ba, na-discuss po natin kanina yung mga different materials na nagagamit sa bearing para sa kanya-kanyang purposes po, whether for heat conductivity po yung kayang mag-stand out po doon. Tapos yung mga polymers for non-corrosion. So dito po sa rolling bearing materials po natin, madi-discuss po natin is all about the commonly used materials ng ating bearings po. So next slide po. So for this table po, it is a representative for rolling element bearings. Ito po makikita nating materials ay most commonly po yung ating nasa loob ng ating bearing materials po. So dito, discuss po natin is representative steels employed for ball and roller bearings are listed in this table. AISI 52100. So basically parang alam na natin ito lahat. So since nakapag SolidWorks tayo at yung materials dito na discuss ay available dun sa stock po ng ating SolidWorks. So bale, IC 52100 true hardened steel is the primary choice for industrial ball bearings and many spherical and cylindrical roller bearings. This higher chromium content, 440 degrees, is commonly employed for corrosion resistance. Carburized steels, example is IC 8620, are used for tapered roller bearings and other heavily loaded types that benefit from the tougher core material and from the case compressive residual stress developed during carburizing. Both types contain 0.6 to 1.1% carbon at their highly stressed contact surfaces to give high hardness. For standard bearing steels, an elastic modulus of 207 GPa or times 30 times 10 raised to 6 psi and 0.3 Poisson's ratio are usually used for calculating contact stresses and EHD film thickness. With their lower carbon content, case-hardened steels are used for the rollers and races of many roller bearings in automotive and railroad equipment for better resistance both to shock load and to cracking with heavy interfaces fits when mounted on shafts. So bali, ito po yung mga bearings natin kapag in-apply natin is may kanya-kanya pong purposes. Gaya po nung kanina, kapag po mali ang ating nagamit na bearing, possible mag-cause po ito ng damages. And pag hindi po natin na maintenance, yun nga po, magkakaroon tayo ng higher problems when it comes to maintaining the life of our bearings. So, bale, many automotive front-wheel drive bearings now use case hardening alloys such as 1570. Large bearings for excavators and cranes employ heat-treatable steel with an increased alloy content of 0.4 to 0.5% carbon. Carbon. Their raceway surfaces are frequently gas carburized or induction hardened. That was based on Ishman 1985. So bale dito, makikita natin puro carburized yung ginagamit since many of our machine and engines are experiencing heat conductivity. So bale kailangan natin maging heat conductive ang ating materials na gagamitin para mas malengthen yung ating bearings life. So the operating temperature limit for IC 52100 steel bearings commonly ranges from 125 to 175 degrees Celsius. As operating temperatures exceed this range and approach the final stabilizing temperature for the steel, the small amount of retained austenite phase transforms into less dense martensite with an increase in bearing dimensions and with some loss of fatigue strength. Case carburized bearings are usually limited to an upper operating temperature of 150 to 175 degrees Celsius. M50 tool, steel, and M50 NIL are commonly used for temperatures above 175 degrees Celsius under severe conditions encountered in aircraft jet engines. Then for ceramics, yung ito nasa babang mga materials, especially silicon nitride or yung Si3 and 4, are being applied in an increasing range of severe conditions. Their unique properties include high temperature capability to 1000 degrees Celsius and above, inertness to corrosion and hostile environments, low coefficient of expansion and low density which greatly reduces troublesome self-loading by centrifugal force on balls and rollers at speeds of 50,000 RPM, and above in machine tools and aerospace equipment. Hybrid bearings using ceramic bolts with M52 seal rings enable operation up to 300 degrees Celsius while avoiding the difficulties in manufacturing ceramic rings. Next po tayong table po. Then yung next table natin di-discuss is all about cage materials. Sa cage materials naman po, typically cage materials used for spacing the rolling elements are listed in table 4.11. Simple low carbon steel strip form and rivet to provide ball pockets is widely used for the slow stress levels on cages in most ball bearings. IC 430 stainless strip is used in the same fashion for 440 degrees Celsius. Bali dito sa ating table na to, dito yung parang basis table na label naman operation conditions, typical material, manufacturing method, and remarks. Yan po yung ating mga experience na materials na ginamit na natin sa mga bearings, and most commonly yan po yung mga applicable and mga applicable po natin mga materials. Yun lang po. Thank you po. Next po.
Gaano pa kahaba ang tira? 4 slides na lang? G, tapusin na.
Sir, bali hindi raw po na ganang mic makuha po.
Basahin na lang yung 4 na slides. Kahit may ano na lang.
Okay po, sir. So, bali po ang next topic naman po natin is polycrystalline diamond or PCD. Bearings are ideally suited for use in extreme environments because of their extraordinary thermal and mechanical properties. So, past use of PCD in process fluid lubricated downhole tool applications such as those in oil and gas drilling turbines have proven them to be robust, long-lasting, and rugged. So, bali nga po, bisa mo po sa ating name, so polycrystalline diamond, so it can give us the robust, long-lasting, and rugged. So while their use is widespread in downhole drilling applications for oil and gas, polycrystalline diamonds or PCD have recently emerged as promising bearing material that can withstand harsh operating conditions such as high load, high speed, and high temperatures, particularly when the operating environments contains abrasive contaminants. Next po. So for dito na po sa table natin, so GPA or PCD exhibits remarkable thermal and mechanical properties as shown in this table. This comparison with 4140 steel and silicon nitride shows more than a 10-fold increase in thermal conductivity, which offers superior thermal performances. Next po. Ilan po. Thank you po.
Ayan. Thank you. So, wait lang. May 4 minutes pa naman. Anong naka-ready sa inyong quiz 3? Pang face-to-face or online? Kasi kung
Sige, face to face na lang. Sige, sa Sunday na lang ang quiz try ninyo. So yun, before, 3 minutes na lang. So thank you sa pasend na lang nung presentation sa akin, katulad ng sa ibang group. Tapos, yun. See you sa Sunday para sa quiz try ninyo at saka sa discussion natin. Wait, nasan na ba yung quiz? Tsaka pa-quiz to din pala ng group 2. So, yun. Kung kaya nyo siya i-prepare ng online, i-online nyo na lang para dire-diretso na yung discussion ko sa Sunday. Tapos, i-online quiz na lang natin yung quiz 2 at saka quiz 3. Which is sa October 1. Nyo na lang i-take. Kasi diba dun ko kayo hindi mamimit. So, dun na lang kayo mag-take ng quiz 2 at saka quiz 3. Yan. Para sa 24 ay pure discussion na lang ako. So yun, so 2 minutes na lang. So dismiss ko na kayo. So lipat na tayo ng kabi-kabilang subject. Ayun po.
Thank you po.
Thank you po.